including social network analysis, complex networks, time-varying networks, opinion dynamics, data analytics, mathematical modeling of epidemic spreading, and efficient tuning in communication networks. Throughout his academic career, Dr. Singh has been dedicated to teaching and mentoring students at various levels. Currently, he supervises PhD, master's, and undergraduate students at NIT Delhi, guiding them in their research endeavors. Now, I would welcome respected faculty members and the chief guest to please come up on the stage.
Good afternoon, all of you. Thank you for inviting me. So, as you heard, the topic was federated learning and its application, but here you are seeing machine learning. All are you from computer science branch or different? Who are from other than computer science branch? Yes, few are. So, first of all, I will share few of the slides so that you can understand the meaning of machine learning. Because it is very much important to know what is machine learning so that you can use it. And this is the buzzword. Nowadays, you can see that everywhere people are talking about machine learning. Have you heard this word? Everywhere machine learning. But actually what it is important to understand so that you can apply machine learning. Because mostly people think that we have to do some work in the machine learning. But machine learning, you are not doing work in machine learning. Actually, you are using machine learning as a tool for your application. Your problem could be from any branch, from any field, but you are using machine learning for certain purpose. So you should correct your statement. You are not doing engineering or research in the machine learning, but you are using machine learning approach. So just see this definition. If you know this definition, then you can understand machine learning in a single line. So this is the Professor Tom Michel from the CMU. He has given the first machine learning definition. So if you see in this definition, a computer program, it is a computer program, okay, is said to learn from experience E with respect to some class of task T and performance measure P. So what does it mean? So here you will see the three keywords: experience, second is task, third is performance. See, you can take example of yourself. Can you perform any task without experience? No. So you learn some experience, then you execute a particular task. And what is the objective if you are performing a task? To execute that task up to the maximum performance. Okay. So actually machine learning is a program which will take some experience from the outside world, and by taking the experience, it will perform some of tasks. One task. If you have certain experience, then you can perform some class of task by using its performance measure P. So there are E, T, P. There are three keywords by which machine learning is defined. If its performance and task in T as measured by P improves with experience E. So who will improve the performance if you are executing a task? Who is the responsible for improving the performance if you are executing the task? Experience. If you have more experience, then so here experience can be gained by the available data set. So in the machine learning, we talk about if you have more data, then you will have more experience and you can execute tasks with the higher performance. So I hope now the term machine learning is clear to you collectively. So it is ETP. So just this is all. Next, I want to show you few slides for you. So this is the explanation of EV and to see this figure. It is also important to see the learner, how learner will look like. Learner is a person who get the experience from the world. So if you are a learner, then what can you do? You can give the logic. Okay. So how learner behaves? If learner will experience from the data and background knowledge which he has previously. So learner basically able to reasoning. So machine learning model does see you make a learner by getting the data from the outside world, and you model it so that it will able to reason. So see what will happen if you are make a machine who can give the reason, then you can solve the problem. So from learner to reasoner, modeling will be done. This is your task. So once reasoner is available, reasoner is a machine who can give the reason, logic. Then you can give any problem or task to that machine and it will answer you. So this model word is actually modeling which you do in machine learning models. Okay, from learner to reasoner. Next. Next. So see how forget about supervised learning. I am not talking about supervised learning. General machine learning structure. So what it will do, it will take the data set. Data set could be only input or input output as basis of the supervised or unsupervised. How many of you are aware with the supervised and unsupervised term? See, if you are not aware, simply say that. In this case, what type of data is this? Input and output. I will show you a fruit and tell this is a orange, this is a banana, this is the apple. So what your mind will do? Your mind will see the color, shape, size, and remember that it is the particular fruit. So that is called supervised data, where all input is given, color, size, shape, and output is also given. So once you will develop a learning algorithm by seeing multiple fruits, and suddenly, so what will happen if we will apply learning algorithm? You will have a model. So what is the model means? Model is a person who knows about all. So once our model, then so what will happen? So what is a model which has learning capability. So first important definition of machine learning, apply machine learning, or the definition of machine learning. When we are applying machine learning, then you need data set. Second, you need model or algorithms. What is the third important thing which you require? Remember that computation. You need a computing power. Why? Because data set is low or high. In the machine learning problem, suppose you are training a person by showing all the fruits. So that fruit data is low or high. See, if you are training the machine by showing the fruit, it doesn't mean you are showing one fruit at a time. You will show one fruit by different means, from top, from side, from this distance, from higher distance. So ultimately, you will have very large data set. So once you have large data set, then computation means you need heavy computing machines. So machine, when you are applying machine learning, then three important components are there: data. Second is model, algorithms. Third is computing machine. So in 20, 30 years back, we are lacking about the data. Data were not available, but algorithms always were available since starting. When we have enough data, available algorithm, then where we are lacking? Computing power. Because once you will analyze the video or higher number of images, then computing power will become the critical issue. So if you will have all the three things in sufficient, then you will get the best prediction machine. Okay. So what he is telling, that is this figure, see, you have a training set, means data by which a model will become learner. So you have a learning algorithm. By taking the training data set, a learning algorithm will able to make a model which have the capability of learning. See, why person is intelligent? Because person has learning capability. If you will show me something, I will learn. So if I will learn, then I will become trained. So same power we are providing to the machines, showing the data set, they should become learner. So that task taken care by machine learning models or algorithms. What will happen after that? There is a term written hypothesis. What is the meaning of hypothesis? See, here hypothesis is very intelligent and important meaning. Suppose I will tell you, I will show you 10 things, or I will tell you some concept for half an hour, like this lecture. Okay. I have given some lecture for an hour, and after that I ask the question. So if that thing will be covered in the lecture and you can relate and analyze the things, then definitely you can answer it. When you cannot answer, there are two ways. Either I have not taught to you, it means incomplete data set. So I'm assuming data set is complete. I taught you everything. If I am asking something, then you are not able to make the hypothesis. You cannot correlate the things, not able to analyze the available information, and you cannot answer. There are two things. Right? So second, hypothesis means if I will tell you something, so there are many ways by which you can answer. Is it correct? See, if I will ask a question after the lecture, so all student will give same answer? No, everyone give different answer. So all can be correct? No, some could be correct. So this is the meaning of hypothesis. If you have a data, you have a reasoning model, then there are many options for telling the answer. So telling the answer means prediction, something asked and you are predicting. So to choose the best one among the available reasoning, it is called best hypothesis selection, and it is the task of machine learning. Because if you have learned model, then if I will give you some input which is not known, then there are many ways. Many ways. It is not many, means very high number of ways, and you have to choose best one. That is the task of machine learning algorithms. Is it clear? Just go back some slides, then I can clear that example. Back. This back. एक बार एक बार back. एक ग्राफ सा आएगा. आगे आगे चलो. There is a graph. एक बार आओ. Suppose this line, है ना? So in this line you can see some points are there. So what is the point represent? If the mileage of this car is this, then price of this. Mileage this, then prices. So if you see, there are seven cars prices are given. So what happened? You make a line. What is the meaning of line? That line is covering all the points. So if I will give you random mileage and ask the price, can you answer? You just check the line and you can answer. But now question is this, how many line you can draw by covering those point? Only one or it could be many. See, some person can say that my line is just below that. Some person can say that my line is above that. Or some person say that my line is this, but some at some angle. So how many possible lines are there to cover all the points? Infinite. Because at a point you can rotate the task of machine learning model. That is best selection of best hypothesis. It is clear? So now open this federated learning. Second slide, PPT. So you have some brief idea about the machine learning. What actually machine learning? Machine learning is a computer program which works on the experience to perform a task to give best performance. Okay, next. So now see, my topic is federated learning. Federated learning is the version of machine learning because see, there is a certain variation. I will tell you why it is called federated. Have you heard Uber? And have you used Siri, Apple Siri? And have you used Google Keyboard? So these are the three best example of the federated learning. And it is started in 2017 by Google for Google Keyboard. See, but do you think that your Google Keyboard is intelligent? Mobile keyboard. Achha, have you ever seen your computer keyboard is intelligent? What is the reason? Why mobile keyboard is intelligent and not computer keyboard is intelligent? Because mobile keyboard is very less and your fingertip size is very high. So if it is not intelligent, you always type wrong. See, I will not give you any prediction, any hint, any spell checker. Then always you will type wrong sentences by using the mobile keyboard. But it will not happen in the case of laptop keyboard, computer or laptop keyboard. So why it is intelligent? Why mobile keyboard is intelligent? Because if you mistakenly type some wrong sentence, it will give you correct. And whatever you will type, it will see what number of words typed by you most. So it will learn whenever you type certain one or two alphabet, it will predict that. And there is one more facility of gesture. You can just do this finger and it will type. So this facility is given only for keyboard, and this is the first example of the federated learning which was implemented by Google in 2017. And then Apple is also used for the Siri, because see, you are telling your mobile phone in various ways. Sometimes your throat is not well. Sometimes you are telling from far place. Sometimes you are telling clearly, sometimes not clearly. But you will be surprised, Siri almost give you the correct result. So it is also an intelligent person. And in the case of Uber, why Uber example I have taken? Do you think that see, suppose Uber collecting the data, you know how Uber collect the data? If you see the app, every data is collected from where you have started your journey up to where you have gone. What was the distance? What are the various locations covered by you? How much travel in a month? So they are doing all the analysis for you. And by doing this analysis, they will predict the next thing. Whenever you are booking the taxi or whenever you are traveling into the taxi, or how much fare they should be charged. So do you think that whatever happening in American traffic, same thing, same prediction should be applicable over India? No. And whatever happening in Indian traffic should be reflected in the US? No. So that is the example of federated learning. So it means whatever central level, whatever learning application we are making, it is not useful for every places. So what should be the good idea? How should we do learning? For India at Indian data set, learning should be done over the Indian data set. For US, learning should be done over the US traffic data set from the Uber, so that we can give the prediction to that particular geographical location. So that type of learning is called distributed. You know, distributed. There are the contrasting word of distributed is centralized. Okay. Currently you are centralized. If I give a task and send to you at multiple places, then it will become distributed. Okay. So first, so how federated learning come into the picture? So the journey starts with data. Data is generated as centralized. Data is generated through the large number of mobile phones, IoT devices. You know IoT devices. All devices, those are connected. This generated data can help to find the better products. So why we are generating the data? So that you can make a learning model by using machine learning and do the better prediction for the future. So this is the aim. We will take Google keyboard example. So tell me how machine learning model will be applied. Your data, whatever you do, whatever type, all of your data has been taken out from your mobile phone, sent to some server and apply machine learning model and tell you this is the result. So is it the correct way? It is the correct way or not? Will you give your all that typed data to any other person for analysis? No. So this is the security breach. So there are, you know, edge devices. Edge. These are all edge devices. Multiple IoT, smartwatch, phone, all are edge devices, and all devices are generating the data. But that data is personal or public? Personal. So for analyzing the data, you should send that data to a big server so that they will analyze, and it cannot be done by because data is personal. So how we should provide the solution? That will be the origination of federated learning. You got the idea? Because you cannot do all the learning process at the central level, because data is important. Nobody will give you personal data to any other person. And why learning is important? If learning is not applied, machine learning is not applied, your system, personal system will not become intelligent. Even your smartwatch will do multiple predictions. If you will walk, then someday they will say, your watch will say, you have this problem. Your number of steps are less. You have to cover this number of steps. So all are learning. If they are not, it is okay. So how learning will be applied? So what should be the idea? We should not take back the data to the central place. What should be the idea? We should do something so that that thing is done at this place only. To the concept of federated learning. First one. So data is born at the edge. Edge devices are the responsible thing. Those are generating the data. So billions of phones. You know how number of phones are there. IoT devices constantly generate the data. Data enables better product and smarter models. So see, if you will not have data, then never you can get the better and better mobile devices. And you see lot of updates you get over the mobile phone. And that updates come after some time. So who gives the feedback about those updates that is required in your mobile phone? So they are somewhere analyzing all the phones and collecting that parameters at some place, and they are making the result. Something is lacking and it should be thrown through the updates. So see this term carefully. Data, if you have available data for applying machine learning, then better products and smarter model can be generated. Next. So these three examples are given so you can understand mobile. And what is this car? Google car. Google car or smart car. Smart car always record lot of data. If you see nowadays cars, then they have lot of data. They will tell you how much kilometer you run, how much mileage is left. And through mobile app, you can access the car information. Have you seen that? So how is it possible? How you can access the information of the car through the mobile? Will you interact with the car directly? See, if you are at this city and your car in another city, then still you can see its location. So who's the responsible for that? Because distance is very high, no communication can catch this. It is coming from the clouds. So car sending the data to cloud and you are accessing information through the cloud. So because of this, it is possible. So can data live at the edge? So data processing moving on device. So what is the idea of federated learning? Whatever data will be processed, that will not be taken out from your device. It will be done over the device only. So that is improved latency. You know the term latency. Latency means if you send something through the wire and whatever time it will reach to the destination. So how much delay it will have, that is called latency. So if you are not sending the data to server and coming back for the analysis, then you can improve the latency because whatever you are doing, it will be done over the system only. Sorry, that device only. Once offline, even your machine is not, your device is not connected with a server, still you can perform the analysis. Better battery life. Okay, battery life will be better. Privacy advantages. So last is the most advantage. Your privacy will be preserved. No data will be gone out, so privacy will be preserved. Next. So what are the federated learning ingredients? I told you already. Same machine learning ingredients will be the federated learning. You need data set. You need models. So that model will become federated learning models because that learning is slightly different. And third is computation. Next. Actually, I have taken this example of the computer vision system. You know computer vision system. So I have given the example for identifying the fruit, that is the vision system. After seeing, you can identify something. If I will show you multiple sports and randomly show a picture and ask what sport is this, you can tell. And you know, nowadays, who have seen the example of video captioning nowadays? Image captioning. Image captioning is like that. I will show you like this image, this poster. So you should not read or see the picture. And suppose a person who cannot see this poster. So how he will understand that what is written over the poster? So how will you make the application? So first I will make an application so that some application will see this picture and write in English sentence. Okay. This picture is showing this. In this picture, a one man is standing in front of the robot. So that is written in English. And what after that, what I will do? I will apply a tool which will convert text to audio. Then that person can understand what is in that picture. So that is called captioning. You know subtitles, right? So subtitle, whatever I am speaking, it is converted into the text. But captioning is that I will see this picture and something is written by the system. Like I am seeing this and I can write this. Some number of boys and girls, faculty members are sitting in the room over the sofa. This is the room, size of this room. So same thing should be done by machine. It is called captioning. So this is also the example of computer vision. So machine learning, I'm just relating how it is connected with the vision. So machine learning emphasizes the design, development, and training of algorithms and software agents to sift through, interpret, and make data-driven decisions based on pattern hidden within the vast data set. Pattern hidden means, suppose I have seen this picture and I found multiple patterns. It is like that. So artificial agents are increasingly being equipped with multifaceted sensory capabilities that allow them to interact more intuitively with their environment. So it's obvious. So vision stands out the most profound, granting machines the ability to see and understand the world around them in ways comparable to human. So I told you, machines should see outside the world like the human. So last point I'm reading, what is the main challenge in the computer vision system? So computer vision system is the protection of user privacy. So I'm telling you why computer vision needs user privacy. Suppose there is a birthday party in your home, and somebody has taken multiple pictures. And after that pictures, you have given that picture for some analysis to machine. Analyze this, write a report, or you need to do some prediction and do this. So what is the concern of privacy? See, it is like that. Suppose I have clicked your room picture. Then nowadays cameras are very much fine camera. You can see every corner, what is written, what is. So somebody can see, suppose on calendar you have written 2-3 passwords. So that camera can capture that password. So once you are applying the vision over the available images, then privacy is the major issue. A main challenge of CV system is the protection of user privacy. Collecting millions of people's images and videos possess serious privacy risk, which must be seriously considered. So if you are analyzing the images and that images belongings from the person, then that is very much important to hold the privacy. So is it clear how privacy is important in the vision? Next. So first of all, the right to be forgotten is constantly violated by companies that collect visual data and retain it permanently or use it for multiple purposes. See, what company can do? They have to rigorous analysis and find the sensitive data. And before the analysis sending to the server, that sensitive data should be erased out. This task should be there. Secondly, the privacy preserving analysis of images and videos surveillance applications for CV methods are used to detect violations. So he's trying to say there are two things. If you still want to do the analysis over the central places, you should carefully watch the picture, find the sensitive content, wash it, erase it, and then analyze over the central server. What is the second idea? Second idea, apply the federated learning. Put the model over your local device and analysis can be done. So that slowly is coming to the federated learning, because first task is not easy. So if you see the last line, the rise of edge computing architectures has introduced a new potential to privacy preserving computer vision. Since with the proper use of limited edge resources, it has become possible to perform. See, if you use mobile phones, then you click the pictures. So in iPhone, after some time, they will create a very wonderful video of all the pictures by detecting your, they can say that this person is with you, this is the place, and these are the 5-10 pictures. So these type of analysis are keep going on. And after some time, they can analyze you have visited with that person this number of places, these number of pictures are there. So all analysis are happening with your pictures. So this is computer vision. So tell me, that should be done over the centralized place or over the device? Over the device. So that is also one of the example. Next. See this example. Some picture has been captured. Okay. So you can see something written in this paper in their office. This is some army office. So maybe that contents are sensitive. This person is going, maybe he is some person who don't want to come in the front of the world. See, he is opening the computer, maybe some sensitive information in the computer. So because of this computer, in computer vision, this thing is important. This privacy issue will come into the picture. So visual scenes include much more information than is needed for a machine learning task. See, that was not our task, whatever circled, but unintentionally it is coming, which is related to the privacy issue. Our task is that what is happening. Suppose you are doing captioning, what these people are doing. Okay. So this is the next. Next. Okay. So how we will go in the direction of federated learning? So this picture will clear you. So centralization makes easy. So here you will see the mobile phone. How traditional learning model applied. So right hand side you will see three pictures. Can you know, do you know what is the meaning of this shape? What is the shape? Cloud. And under the cloud there is a, so that shape is called disk. Last one. And in middle it is TF, TensorFlow. Actually, it means it is a machine learning model, some machine learning model. So model is a person who will apply the learning capability over the data. And so machine learning model needs what? Data. So that green color is not data. So that data is lying over the disk. And disk data will be taken by machine learning model for making a learning model. And what is happening? This is your mobile. In mobile, some application is run. There is local data by red dot. That local data should be given to the server cloud, and that model will process that data and will generate some parameter. So green color is, see, once you apply data over some model, then you will generate some parameter, some output which is required. That is also given to the cloud. Because generated parameter again helps to improve the model. See, whatever you are seeing is TF. It is learning model. Initially, it was unknown. Slowly, it was become known. So whenever you will have new learning parameter, that model will try to improve itself. So this is the idea which is called centralized processing. Next. So now in the centralized processing, see what operations are happening. Cloud is requesting data from the device, and prediction, whatever predictions are made, that will be supplied to the machine, because ultimately machine need the prediction. And on the basis of prediction, some feedback is going to the cloud. According to the feedback, they are studying every software is going fine or not, or update is required or not. So these three actions will lead which problem? Latency. Because ये किसी wire या wireless device के through once you will communicate, then you have to spend some time. So these three things will lead latency. So we want to remove latency. And what we want to remove, we don't want to give data to cloud. So that is also crossed. So disadvantage in the centralization approach, latency doesn't work offline. Means if you want to send data to cloud, you need an internet or some connection. Eats battery. If lot of communication will happen, then mobile battery will be drained. You have ever noticed or ever known this thing? Your mobile data is going out in for the processing, and its battery is draining. You know, mostly people when people do this thing, कब मोबाइल के एनालिसिस कर सकते हैं? Because it will eat your battery. Suppose you are lacking battery at the daytime, and it is processed when you are putting your phone at charging. This analysis is also done in your mobile phone when your mobile phone is free with full battery, or when you keep your mobile phone in the charging port. So when it is with the charging port, then they will do all this exercise. So data cap is the problem. If you have less data, then some of the data is too sensitive to collect or too large. So it is hard to send all the data to cloud because of the sensitive data. Next. So learning locally at device. So what solution they have defined? You put data here, you put model here, and all the learning parameters should be here. So what will happen? Nothing leaves to the device. So confidentiality or privacy should be there. Sometimes not enough data per client to train a good model. See, if I'm as a company, mobile company, only studying a person's mobile data and give the prediction to that person, is it a good idea? So what is the good idea? I have to do similar exercise with all the person. with most of the persons and see the output. Output doesn't mean data. Whatever predictions are made, that should be taken by the server and make a good model and again deploy to the machines. So that thing can be done in the updates. So this is also not good because nothing is happening over the server side. So centralized analysis is not happening. Next. So what we can do? So we can do the parameter which is taken from this. So this is one side model. So instead of empty model, we will put some pre-trained model which is trained over the server. Pre-trained means some person who knows something. And then he will give it to your mobile phone. Then he will learn more about the data and will give the better prediction. Next. But this is the best model. What is the role of that model? It will take the data from the, local data will be trained and whatever parameter analyzed, it will go to the cloud and whatever, and over the cloud, this model will be improved. And after improved, again, it is deployed over the machine. But in this example, only one mobile is connected. But it should be, there are large number of mobile connected. All the parameters will be taken by the server, improve the model and deploy it. See, none of the mobile user can generate the machine learning model and deploy over his or her phone. That should be deployed by the cloud. ठीक है, मॉडल आपको नहीं बनाना है, मॉडल ऑटोमेटिकली जो भी मोबाइल कंपनी है उसका सर्वर उस पर आपके मोबाइल पे डिप्लॉय करता रहता है, so that local training will happen. Next. So now you can see, this is the thing. So multiple mobiles data after training coming to this. So you can see multiple parallelograms. So multiple parallelograms are training data, after modeling, after applying this training model over the available data, whatever parameters are generated, that are going to the server. And here you are getting plus sign. Plus sign is called aggregation. Aggregation means combine all. And generate a improved model that is called federated model. And that improved model will be deployed over the mobile phones. And again, this thing will happen. Again, new parameter will be generated. So that cycle will go on. So tell me when this cycle will be stopped. Or lifetime it will go on. So it is keep improving. There are two things. If you want to keep improving, then you always run the model and try to improve the model. The another idea is that see, every time you check that the prediction is accurate or not, whatever you are doing. If accuracy will become 100%, then is it required? So, or you can put the threshold up to this accuracy, it is stopped. Okay, otherwise it is keep improving. So in this case, it is not collecting the data. It is only collecting the trained parameters. Only. So what is the advantage of federated learning? इसको next कर दो हम. Next करता है. So the core idea behind the federated learning is centralized learning. Sorry, decentralized learning. It will be. Users' data never sent to the centralized server. First, find the suitable devices available and deploy the model over them. Achha, this is also the thing. How many mobiles are there in this world? Millions. So can you collect that? See, every Android or iOS application will be uploaded by another third party. So they are keep tracking how they are performing. They are also applying this thing. So can they apply this? Can they deploy this trained model over the all devices and collect the data? It is very hard. So they have to select some of the devices so that I can throw the model and that model will run your local data and it should come to me. So for that, there are some conditions. So we will deploy the model over the mobile phone, which will generate the data. if there is a mobile phone which will not generate any data, some people don't click any picture, don't type anything, just call. So definitely that mobile phone should not be selected from the for the analysis. And find the suitable devices. And second, that mobile phone should have data. If mobile phone don't have data, then we cannot deploy the model from the cloud. And they should have battery. So what will happen in first cycle? This number of mobile phone model is deployed over certain number of mobile phone. Model is trained, parameter come to the server, and model is improved. So when we went back, deploy the model over the available mobile phone, so will we get same mobile phone or different? Why? Because some mobile phone may be switched off. Some mobile phone don't have data. Some mobile phone lacking the battery. So maybe in second round, set of deploying the model, the mobile clients will be changed. And same thing will happen third round. So in multiple rounds, you will see the devices will always be vary. So this is the problem. So first find the suitable devices, available data, and deploy the model over them. So you cannot deploy a model all over the available devices. You have to select whichever is best for your learning. It is called sample. We always find the sample. You need to collect the sample for your learning. So better to choose which is suitable. All clients could know have sufficient data to train the model. Find suitable device and deploy the model over it. Next. So these are the things you can see. There are certain bunch of mobile phones are there. See, in first case, like none of the mobile phone have data or power, then it is called not available. In this, all will have data, then it is called available. It is available. It is suitable available because mobile phone having data but are in less numbers. Next. So how it performs? Each client trains the model locally, uses its own local data. Client means mobile phone. See, it is not only mobile phone, it could be your Google car also, because car data is also private. It should be your, in healthcare, lot of machines are there. And that machine stores the patient's data. So patient data is also private or public. So in healthcare also federated learning is used. You should major healthcare, transportation where car data, personal car data is available. Third, edge devices like wearable devices or this mobile phone. It provides a new, so each client trains the model locally using its own local data like this. It provides a new model which is sent back to the server. Okay. So server will get only parameters learned by the client need from them. See, if model will be trained and applied over the available data, it will generate some parameter, whatever predictions you require. So that parameters will be sent to the server, not the data. And this parameter is also in the form of encoded. Encoded, it is logged form. It will go with log. The person who has key, only they can open from the server. So data used to train that data never leaves the device. Data will never leave the device from the mobile phone. So federated learning enables mobile phones to collaboratively learn a sharp shared prediction model while keeping all training data on the device. Next. So this you can see. There are 3 clients. Some local model will run over that by the local data set, and that parameter will be passed to the, and that parameter will be pruned and new model will be generated. And again, new model will be deployed over the mobile phone or edge devices. Second. So again, this is the same example we have already discussed. All the parameter will come and model will be changed. You can see by aggregation. Aggregation, see, first mobile send 3 parameters. Second mobile send 3 parameters. Third mobile send 3 parameters. So what we are doing at the side of server, aggregation means we have taken two parameters from first and second. See, purple color. Purple color is coming from first and second. So it means there is one parameter which is taken care by two. So that will be taken at one place. Green one taken one place and yellow and circle. And after that, aggregation will be applied. Aggregation is not the direct sum. So we put parameters separately, their aggregation, because one different parameter cannot be added with the another parameter. So no individual updates stored into the clouds. And what we will do, every time this parameter will come, new model will be made, then previous will be washed out. It will not be saved. And again, new parameter will come, model will be deployed, previously will be washed out. So no individual updates stored into the clouds. Client data will always remain there. Server pairs up the devices with other in a buddy system. So it is paired with the desired parameters. Each device has two buddies. Data from each device combined with the random values before being sent to the servers. So I told you when parameters sent to the server, it is encoded, not directly. Server know the values and send to the buddies and connect them out to the just the payload. So server will have key to encode that data and accordingly they will taken out the parameters. Next. For major security, they also encoded the parameters also. Next, next detail. Yeah, next. So this is the Gboard example, if you will see. Huh? So see, so what Google Board basically do intelligent tasks, it predicts the emoji also. If you will type, then it will predict the emoji. It will predict the word. So see, it predicts the word as per your typing or as per our whole world typing. See, sometime your and sometime in by general dictionary also. So tab typing models. So why machine learning model is required for keyboard? Tab typing. What is tab typing? You know this, no? Gesture typing. This one is gesture typing. Yeah. See, this line is looking very fine, but once you do this on your mobile phone when you are typing and just try to see the image over that, then there is very moti line. ऐसे black मोटा spot आएगा. So what machine learning algorithm do first that fat lines will become thinner. So that sharp converting to the sharp line. And then try to understand which is coming perfectly over that. Otherwise आपका thumb ऐसे जाएगा, finger ऐसे जाएगा तो बहुत मोटी line बनती है. तो machine learning algorithm apply which character actually you want to touch. They predict and then accordingly do. So all things will be done simultaneously. So auto corrections are there, predictions are there, voice to text also there. So once you do voice to text, then also intelligent system is there and more. So whatever you are doing, that data will be stored for further processing, for further analysis, and you need to do all the machine learning modeling at the device only. Next. So this is the next word prediction. So if you will see the blue dot, that was the some previous model before the federated learning. So once they apply federated learning, then it is improved much more. So it was applied in 2017. So this was the first paper where they applied federated learning in the Google keyboard. So federated RNN compared to the prior n-gram model. So previously they were using n-gram model. So 24% accuracy is increased. See, initially also Google keyboard before 2017, but algorithms were different. So I don't know, have you ever noticed or not, after 2017 or 18, Google keyboard will become more intelligent than the previous. More useful prediction strip, 10% more clicks are there. So what for the federated models do in Gboard? Emoji prediction. So after federated learning, it will become 7% more accurate. prediction strip clicks increased 4%, 11% more users share emojis because of the intelligence. अब जैसे you are typing emoji come then you can click, but nobody typing and then selecting emoji, so emoji use increased by 11%. Action prediction, discovering new words. So all these three papers are there relatively to which improve this part for your Google keyboard. कितना time था? So if somebody is interested how they applied emoji prediction, action prediction, discovering new words, so these three respective papers are there. So what are the real life applications of federated learning? So first, as we have seen the smartphones. So in smartphones, how are most common ways to witness federated learning in action? Word prediction, face recognition for logging, voice recognition using Siri or Google Assistant. What is the name of Google Assistant? In phones, nobody knows. And Gemini. Gemini. And what is in this? What is the name of that machine? Google Pixel. Google Pixel uses Gemini. And what is in Android phone? Same. So actually, in whatever way you are answering, it tells that the uses of that. Siri is mostly used, Gemini is rarely used. So it helps personalize the user experience while maintaining privacy. So if they will not do, somebody can say that why are you doing machine learning even on my mobile phone? If we will not do, then we cannot improve personalized user experience over there. Transportation is also one of the uses of federated learning. Self-driving cars use computer vision and machine learning to analyze the surroundings and interpret the learning in real time. See, if you know some cars are there nowadays, which can, if there is no driver, then they can detect the surroundings and can stop themselves. So how it is happening? Because they are collecting multiple data from the outside the world. So if they are collecting the data, some analysis is going on. So that type of analysis should be in the decentralized way. Next. In healthcare, this is the main uses of federated learning. The sensitive nature of healthcare data and its restricted access due to privacy issues make it difficult to scale machine learning system. So I told you there are many healthcare machines which stores the patient personal data which require the analysis. So their federated learning models are very much useful. So in the second point, if you see additionally, FL can allow clinicians to gain insights about the patients or disease from wider demographic areas beyond local institution and grant smaller. I'm giving you this example. You know there is a disease diabetes. See, there is a real example. If you go to the Indian doctors, they will say that you have one, suppose you, and doctor knows that it is closely related to the diabetes because of diabetes. So 120 is normal. So 120 is normal and person has problem. So how what doctor will say? The person don't have diabetes. So that problem may be because of some another reason. Then they start diagnosis another thing. So in whatever example I'm telling you, that patient went to a doctor. That doctor has international experience. Previously, they were going to the doctor, those who experience in the Indian patient. Then the doctor told, for you, 120 is higher diabetes. So because of this, you have a problem. Are you getting? So how this is possible? Until you will not get the data from every geographical locations, you will never get the better predictions. Okay. So as I told you in the Uber example, getting country, it doesn't mean it is fine. One prediction will not be over the other. Some information will be required in future. That happened in America because of this reason. So all things are required. Because of this, he has written disease from demographic areas beyond local institutions, smaller rural. Temperature. Suppose you have given the mobile phone to multiple persons and ask that person to do at multiple places. I want to get the maximum temperature of this region. So that is the example of that. So what we are doing, privacy technology on device data set. So in this case, every machine will have their own data set. Right? Next. So what will happen? Define what they have done. Taken the average of all the. Next. So see, in this case, what they have done, they try to change the model. So how they will change the model? They put an engineer over the server side. Now that engineer will tell that we don't require every temperature from every device. We require only a certain temperature for every device. So what that engineer will do? That engineer will change the model over the cloud or server side and fix this constraint. What constraint? Threshold. Threshold is 70F. You know the threshold meaning? Beyond this. So once engineer change the model and this change model deployed over the devices, then aggregate will not be 69.5. Then aggregate will be different. So which temperature will reaches to the server from the sensors? Only which is greater than 70. Next. So if you will see sensor readings, maximum temperature, threshold. Now threshold is deployed. Model changed and threshold will be deployed over the all devices. So what will be the output? Fraction of sensors with reading greater than the threshold. Next. So now who is satisfying the threshold will be 1. Who is not satisfying the threshold will be 0. So now only that temperature can be. So the meaning is that if you want to change it, that changes can be deployed from the server side only. Next. So whatever result will come by one value only, that aggregation will be taken over the server. That is called federated mean. So this is called federated aggregation, which combine the reports from multiple devices. Next. So only in aggregate, engineer may only access combined device report. Engineer can see the combined reports, not the every reports because of the security. So nobody at the server side will know that which information is coming from which device. Next. So here, you know ephemeral reports. What is the meaning of this? Ephemeral reports means whatever reports will come and next report will come, the previous report will be washed out. Not all the reports will be stored. So that is called complete federated computation, which will be done over the server side and condition can be put by changing the model. Next. So this round will be repeated again and again and again, and every time previous report will be deleted from the server side, and we will find the better prediction. Next. So how Gboard word counts work? Just see this example. So relative typing frequency. So once you type multiple words over your Google keyboard, they will record. Then you will create the data set. Huh? So see, your mobile phone is also storing your local data set, and that data set is not stored permanently. It is stored for some time and clean previous one and store new one. Otherwise, your memory will be full. So this person types typing frequency of high is highest and second highest is high. So why high is storing? Because once you type HI, then he can predict your HI means this, that, or what. So it will record how many words typed by you by HI. So this is the frequency of common words typed from the HI. Next. So what they will do? So federated computation, there will be a data. We will do for word and device data. Search in your device. They are searching that hello world in your device. Next. So see, first device typed hello 18 times and second device typed world 0 times. Next. And device typed hello 28 times and 4 times. So similarly, every device typed hello sometimes and world sometimes. So what server will get? Server will see that the hello typed 251 times by all the devices where model was running and world typed by 128 times. So it is focused collection. Why focused collection? Because engineer has deployed a model for collecting the information of hello and world. Next. So if you will see hello and world, the number of this, so accordingly further prediction can be made over the words over there, according to the frequency. So what property by the federated learning, client data never leaves the device, so that security can be preserved. Per client models are ephemeral. Why? Because whatever data will go to the server and next time it will be deleted after aggregation. Server only aggregates them, cannot see the private data. Aggregation can have strong security guarantees because it comes encoded form. Aggregation result can satisfy different privacy property. Next. So federated learning is collaborative and decentralized machine learning. So actually it is the machine learning model which is implemented in the decentralized manner. It is used to create a smarter model with lower latency and less power consumption. So we know that less power consumption because nothing we are sending to the server multiple times. Users' privacy is there, no data is transferred to the server. And this approach has another immediate benefit in addition to the update share model. The improved model on your phone can also be used immediately, powering experience personalized by the way. So every time you are improving your personal experience. So this concept is new and much more need to come under the federated learning part. Next. So this is to make federated learning possible. So what is the major problem in the federated learning? Once you are doing the aggregation, then every time your devices are changing. So main question is that from which devices you need to take the data for aggregation. So that is called how you will apply the optimization algorithm from the server side. So I don't know you are aware with this stochastic gradient descent algorithm. How many of you knows it? नहीं अगर नहीं भी पता है इट इज वेरी सिंपल स्टोकास्टिक ग्रेडियंट डिसेंट क्या होता है जैसे मान लो इस कमरे में हमें कोई सॉल्यूशन ढूंढना है ठीक है वो इस कमरे में ही है तो कमरे में पॉइंट कितने डायमेंशन का होगा 3 डायमेंशन का। तो हम पता है कैसे सर्च करते हैं पॉइंट, मैं इस बाउंड्री पे कोई एक रैंडम पॉइंट ले लूंगा, बाउंड्री से ही आना है, तो बाउंड्री पे एक रैंडम पॉइंट ले लिया, सॉल्यूशन इस कमरे के ही अंदर है, इतना हमें पता है, तो बाउंड्री पे पॉइंट ले लिया, ठीक है, और एक वहां से टेंजेंट बना दो, टेंजेंट जानते हो, जैसे एज्यूम कर लो सिंपल केस के लिए, ये कौन सा फिगर कहते हैं इसको, ऐसे बना पैराबोला, तो इसमें इसमें अगर हमें मिनिमम सॉल्यूशन ढूंढना है तो कहाँ पे मिलेगा, नीचे बॉटम पे, तो हम कोई भी बाउंड्री पे पॉइंट ले लो, बाउंड्री पे, और वहां पे एक टेंजेंट ड्रॉ कर दो, टेंजेंट ड्रॉ करना आता है, जब टेंजेंट ड्रॉ करोगे तो हमें नीचे सॉल्यूशन लेना है ना, तो पहला पहला चेक करो एक्स नॉट सॉल्यूशन है, एक्स नॉट कब सॉल्यूशन होगा, जब टेंजेंट 0 होगा, लेकिन 0 नहीं है, तो क्या करोगे, एक्स नॉट में से माइनस कर दो वो टेंजेंट की वैल्यू, तो लिखोगे एक्स नॉट माइनस ग्रेडियंट या डिफरेंशियल ऑफ दैट जो भी फंक्शन है उसका, तो हम कहाँ पे आ जाएंगे, नीचे आ जाएंगे, फिर नीचे एक पॉइंट आएगा, तो हम क्या करेंगे, एक्स नॉट माइनस टेंजेंट किया था ना, तो टेंजेंट को पता है क्या बोलते हैं, डायरेक्ट जो डिफरेंशियल है एफ एक्स का, वो डायरेक्शनल वेक्टर कहलाता है, कि हम इस पॉइंट से जाना कहाँ है, तो वो नीचे ले जाएगा, तो एक्स नॉट माइनस डिफरेंशियल ऑफ दिस, तो डिफरेंशियल के साथ एक कांस्टेंट का भी मल्टीप्लाई करते हैं, इसे ईटा बोलते हैं, तो ईटा क्या करेगा, डायरेक्शन के साथ उसको स्केल भी कर देगा, तो उस पॉइंट से कितना नीचे आना है, फिर आ गए, फिर चेक करो ये x1 पॉइंट, तो आपके इक्वेशन क्या बन गई, x1 इक्वल टू x0 माइनस ग्रेडियंट ऑफ दैट फंक्शन इनटू ईटा, जब नीचे आ गए फिर यही काम करो, चेक करो ग्रेडियंट निकालो, 0 है नहीं है, फिर क्या करो, फिर वो x1 माइनस ग्रेडियंट इनटू ईटा, तो ईटा क्या करते हैं, ईटा वैल्यू क्या है, इतना बड़ा बड़ा अगर मैं ग्रेडियंट बार बार बनाऊंगा तो मिनिमम पे पहुंचूंगा या मिस कर जाऊंगा, मिस कर जाएंगे, तो हर बार क्या करते हैं, ग्रेडियंट को कम करते जाते हैं, सॉरी ईटा को, ईटा स्केल है ना, उसको कम करते जाते हैं, कम करते जाते हैं, तो हमें वो ग्रेडियंट मिल जाता है, यही स्टोकास्टिक ग्रेडियंट डिसेंट है, बस समझ में आया, तो इसकी इक्वेशन होती है एक्स के प्लस 1 इक्वल टू एक्स के माइनस ईटा के इंटू ग्रेडियंट ऑफ दैट फंक्शन, जो वो पैराबोला का फंक्शन है, यही है बस ग्रेडियंट, तो वो क्या आपको नीचे ले आएगा, और अगर ऐसा पैराबोला आपको मैक्सिमम ढूंढना है तो उसका उल्टा कर दो, प्लस कर दो, ठीक है, सो दिस इज ओनली द गेम ऑफ मैक्सिमम मिनिमम, बड़ी बात नहीं। So in a typical machine learning system and इसी को optimization कहते हैं, to choose that value which is minimum and runs on a larger data set partitioned homogeneously across servers in the cloud. तो कौन सा हमें डेटा लेना है, कौन सा नहीं लेना है, वो stochastic gradient descent से डिसाइड होता है, तो stochastic gradient descent में we are actually finding those 4 points which are lying over the minimum, तो मैंने बता दिया हर बार कैसे करते हैं इसको, रिकर्सिव मेथड बोलते हैं। Such highly iterative algorithms require low latency. अब ये iterative algorithm है ना, मैंने बताया पहले x0 निकाला, फिर x1, फिर x2 until you will get tangent 0. So these are called not recursive, sorry, iterative algorithms. So these require low latency, high throughput connection to the training data. But in federated learning setting, the data is distributed across millions of devices in a highly uneven fashion. In addition, these devices have significantly high latency, lower throughput connections, and irregular available for training. Actually इसलिए irregular कह रहा है because every mobile will have different amount of data. किसी के में ज्यादा data है, किसी के में कम है. So totally uneven data is available. So this is the challenges in the federated learning. Just wait. So this is just mathematical function. Say there are multiple machines. So if multiple machines of FKW is coming. So suppose for first client F1W is coming, second client F2W is coming. So these are the federated value parameters. So how much weightage we should give in that is this is decided by the PK. तो ये हम सब इसी को federated mean कहते हैं. So this is the formula of federated. So I am stopping here now. So I thought you got the idea of this concept of federated learning where we have to apply, and we have seen a lot of real world applications. People are applying those. And how actually it works. So major problem in the federated learning is this, how you will get the optimized, because once it will come over the server, aggregation देखने में सिंपल लग रहा है, बट दिस इज द मोस्ट टफ पार्ट. तो फॉर दैट वी हैव टू अप्लाई मल्टीपल एल्गोरिथम्स. क्योंकि अभी तो मैंने तुम्हें बताया एज एज के सहारे आ गए. तो अगर तुम्हारा पैराबोला बहुत बड़ा है, बहुत स्पेस है, तो इट विल टेक लॉट ऑफ टाइम. तो वी नीड सम मेथड के जो हमें बीच में से ऐसे नीचे लिया. सो देयर आर मेनी मेनी वे, many researches are going on to get the optimal solution in the less number of time. ठीक है. So if you have any question you can ask.
Online participants, if they sorry, participants, if you come this session to please plus performance will be the session to start with.
These has truly added immense value to this program. Now, I would like to invite Naveen sir to end today's session with vote of thanks.
Thanks, Mr. Team and institute. We would like to extend our sincerest thank you for your talk on federated learning. So, for such an insightful and real world example that you have shown, along with the basic machine learning techniques. So, thank you, sir. Thank you for taking such a long trip from Delhi to visit.
I would request Dr. BTK Pathur sir to please present this token to the convener of the program, Naveen sir, Vivek sir, and Shashank sir. I request Dr. BTK Pathur sir to please end the faculty development program with his vote of thanks.
Thank you. पहले thanks to the students. अभी lunch time हो गया, लेकिन we'll take short 5 minutes time, 5 minutes more. First of all, I thank the speaker of the day, Sri Dr. Anurag Singh ji from NIT Delhi. He gave a very nice talk. I think सब लोगों ने enjoy किया है. And I think I hope your coming years in third year and fourth year you are going to uh, do work in the area of machine learning and projects. So इसमें आप apply projects जो भी आप लोगों ने पढ़ा है उसको you can apply that in different, identify some problem and apply that. It's a very good concept. So thank you, Anurag, and I also thank the conveners of this particular FDP program, mainly Naveen ji, Sasank ji, for organizing this particular FDP very nicely in online and offline mode both. Hybrid mode में इस FDP को बड़ी short notice में organize not possible. And I also thank my departmental student organizers. They also supported a lot for making this a grand success. In coming days, we continue organizing such events like for students and for faculties and the outside world also. So I hope you all enjoyed this particular event, particularly this session and all the online sessions. Thank you all. Thank you. Thanks again to all organizers. Thank you. पार्टिसिपेंट के लिए एक अनाउंसमेंट था कितने बजे 4 बजे एट 4:30 ये ऑनलाइन
ये सबसे छोटा महीना साल का
हमने सारे बच्चों को फोन करके वो ये ज्यादा यूसी है। अच्छा उनके मन में ये डाउट है ये तो चौथे सेमेस्टर तक ही एडवांस क्यों लिया जा रहा है।
तुम्हारे ऊपर फाइन चल रहा है 100 रुपये पड़ रहा है।
वही बताया कि 30 दिसंबर लास्ट डेट था इसके बाद ये फाइन चल रहा है तो बोले कि सर अभी तो पेपर भी नहीं हो। मैं कहा देखो वो सारी बातें तुम्हारी सही है कि आईटी का रूल है एक सेमेस्टर पहले फीस जमा करना होता है नहीं जमा करेंगे तो फाइन लगेगा तो ज्ञान बता रहे थे।